Okay, let's dive into something that feels a bit like finding a secret key,
Mm.
for making AI assistants genuinely more powerful.
Mm-hmm.
You know how some AI tools just seem smarter,
Yeah.
better at figuring things out, not just spitting back info?
Yeah, definitely. There's often something more going on under the hood.
Exactly. And a big part of that seems to be how they're prompted. We're talking really sophisticated system prompts, the kind that actually embed problem-solving strategies.
Right. These aren't just simple be helpful instructions. They're more like detailed blueprints for how to tackle different kinds of problems, like an internal playbook.
Totally. But here's the thing, the challenge, what we're kind of calling the system prompt gap.
Okay.
While they're really advanced models, maybe internally at big labs or in some cutting-edge apps, might be using these complex strategy-filled prompts. Most people, most developers building stuff with LLMs.
They're using much simpler ones.
Yeah, often very basic system prompts.
Yeah.
Or sometimes, like, none at all. It's like,
Okay.
imagine trying to teach someone woodworking. A basic prompt is build a shelf. A sophisticated one gives step-by-step plans. But what if the best way depends on the wood you have or the tools? That's where the gap is.
Exactly. You're missing that dynamic coaching. Teaching the AI how to figure out the best approach for the situation. And that's precisely what our source material gets into today.
Mhm.
We're looking at this really interesting new paradigm called system prompt learning, SPL for short.
And our source for this deep dive, it's an article from Hugging Face. It's titled System Prompt Learning, Teaching LLMs to Learn Problem-Solving Strategies from Experience.
Sounds promising.
Yeah. So our mission today is basically to unpack this. What is SPL? How does it actually work?
Yeah.
And, what could it mean for the future of AI problem solving?
And it's interesting to frame this in the bigger picture of how LLMs learn. There's been talk, Andrej Karpathy mentioned this idea of a potential third paradigm.
Oh, yeah.
We have pre-training that's learning facts, patterns, the what, from massive data.
Right.
Then fine-tuning, teaching specific behaviors, styles, the how to act.
Got it.
System prompt learning feels like something different. It's about the AI learning explicit, general problem-solving strategies directly from experience. It's learning how to solve.
That's a really key distinction. It's not just learning what or how to sound, but the actual how-to of thinking through different challenges, learning strategy.
Yeah, learning to build and refine its own sort of dynamic rule book for tackling problems.
Okay, so system prompt learning teaches AI strategies from experience.
What, specific abilities does that give it? What does it actually do?
Well, the fundamental shift, and this is pretty cool, is that the AI stops treating every query like a brand new thing, completely isolated.
Ha!
With SPL, it starts building cumulative knowledge. It learns and actually improves its problem solving over time based on the interactions it has.
Okay, so it's not constantly hitting the reset button. It remembers what worked.
Yeah.
The source mentions several key capabilities this unlocks, like it builds a knowledge base of strategies.
Exactly. It actively creates these strategies, stores them, manages them in what they call a dynamic system. And this seems crucial. It learns to automatically classify problems like, is this math? Is this coding? Is this a logic puzzle?
Yes, it figures out the type of problem first. The article mentions categories like arithmetic, word problems, coding, and so on. About 16 types, I think.
And why is that important?
Because once it knows the type, the system can then go into its knowledge base and pick out the most relevant strategies it's learned for that kind of task. It's matching the right approach to the problem.
Makes sense. And it's not static, right? It
Yep.
actually improves the strategies.
Correct. That's another core capability. It learns which strategies lead to success, and it actively refines them. Makes them better based on feedback or results.
Wow. So it's an iterative loop for the strategies themselves.
Yeah. And the last piece, which is super important for trust and, development, is that these strategies it learns, they're designed to be human-readable.
Really?
Yeah. You can actually look at the explicit steps the AI is planning to use.
That transparency is. It's huge. It's not just some black box getting smarter. You can actually peek inside and see the learned logic.
Exactly. It gives you a window into how the AI has learned to reason about certain problems.
Okay. This sounds good conceptually, but does it actually work? The article talks about results, right? They tested it.
They did. They evaluated SPL using, I think it was the Gemini 2.0 flashlight model after it went through a learning phase.
Yeah.
And yeah, the performance gains are pretty compelling, especially on harder tests.
Okay, give us the numbers.
So on optillm bench, that's a benchmark focusing on complex reasoning, tricky problems. The baseline model got 61%.
Right.
With SPL enabled, that jumped to 65%. So a solid 4% improvement.
Okay, 4% is noticeable. What else?
On Math 500, which is, math problems, the baseline was 85%. SPL nudged that up slightly to 85.6%.
Smaller gain there.
Yeah, but still positive. But here's where it gets really interesting. Arena Auto Hard. This one tries to simulate those challenging multi-step problems you might actually face using an AI assistant. The baseline score was 29%. With SPL, it shot up to 37.6%.
Whoa, hang on. That's an 8.6% jump on a benchmark specifically designed for difficult real-world type problems.
Yep, a really significant leap.
That feels like the difference between an AI hitting a wall and one actually figuring out a tricky task you give it.
It really suggests it's learning effective ways to navigate complexity. And there's one more, AME 24, based on advanced high school math competition problems. Super tough.
Okay.
Baseline was 23.33%. With SPL, it reached 30%. Another big jump, 6.67% on notoriously hard math.
Wow, so it seems like the improvements weren't just across the board, but they were particularly strong on the benchmarks where strategy and sophisticated problem solving really matter.
Exactly. It really backs up the core idea of SPL that explicitly teaching the AI how to approach problems, not just feeding it data, pays off, especially when things get difficult.
Okay, I'm sold on the what and why. Let's get into the how. How does this strategy learning actually work? You mentioned a dynamic database.
Yeah, think of it like the AI's ever-growing strategy cookbook or library. It's where the knowledge lives, and it's constantly evolving through this cycle.
And the first step in that cycle is problem classification. You said it sorts queries into types.
That's right. When a query comes in, the system first has to figure out, okay, what kind of challenge is this? Is it math? Is it coding? Word problem? Logic? That initial diagnosis.
Got it. Once it knows the type, then what? Strategy management? That sounds like the engine room.
It pretty much is. This covers several key actions. First, creation. If it sees a problem type it hasn't really dealt with before, it'll try to generate a new strategy from scratch.
Okay.
Then, selection. For any given problem, it looks through its library and picks out the most relevant strategies it already knows. The article says it can select up to 3 to guide the response.
3 strategies combined.
Potentially, yeah. To inform the LLM. Then comes evaluation. After the LLM uses the strategy, or strategies, and gives an answer, the SPL system looks at the outcome. Was it successful? Did it solve the problem well?
Right, and based on that.
Refinement. Strategies that worked well, or maybe ones that almost worked, get tweaked and improved. The source mentioned this might happen, say, every 10 times a strategy gets used. It learns and adapts.
Constantly optimizing.
Exactly. And finally, maintenance. To keep things efficient, the system will merge strategies that have become very similar over time, and it'll prune out ones that consistently perform poorly. Keeps the library clean and effective.
So it's this whole ecosystem.
Yeah.
Create, select, use, evaluate, refine, clean up constantly.
Yeah, precisely. A continuous loop aimed at building better and better problem-solving approaches.
And the final step is system prompt augmentation. How did that fit in?
Right. So once the system has selected the best strategy or strategies for the current problem, maybe even just refined one, it takes that strategy.
A human-readable one.
Yes, the explicit steps.
Right.
And it dynamically injects that into the system prompt that gets sent to the main LLM for that specific query.
Ah, so the system prompt isn't static anymore. It's customized on the fly with the best learned strategy for that particular problem.
Exactly. It's giving the LLM tailored expert guidance based on the SPL system's accumulated experience.
And because the strategy is human-readable, you could, in theory, see exactly what advice the LLM is being given for that task.
That's the idea, more transparency into the process.
Okay, this is making sense. And the article gave an example, right? A strategy it learned for word problems.
Yeah, and it's fascinating because it looks a lot like how you might teach a human student. It's very structured.
Walk us through it. What did it learn?
So step 1 was basically understand, which breaks down into read the problem carefully, identify the actual question being asked, and list out all the key pieces of information given.
Okay, basic comprehension first. Makes sense.
Step 2, plan and translate. This is about setting things up. Define your variables, figure out the units, identify the relationships between the numbers or concepts, set up the equations, and, crucially, check for unit consistency. It's about translating the words into a formal plan.
Turning it into math or logic.
Right. Step 3, solve. Now you execute the plan. Show your work, keep track of the units as you go, and do the calculations carefully.
Standard procedure.
And finally, step 4, verify. Does the answer seem reasonable? Does it make sense in the context of the story? And then state the final answer clearly, including the units. It's that final check and presentation.
That's remarkably methodical. And the AI learned to articulate that process itself.
Apparently so, through the SPL process. And they gave some stats from a training run, too. After just 500 queries, the system had created 129 strategies, refined 97 of them, merged 28 similar ones,
Wow.
and successfully resolved 346 problems using these evolving strategies.
It really shows the dynamism. It's not just learning one thing, it's constantly creating, tweaking, merging, actively building its expertise.
Exactly. It highlights that active, ongoing learning process based on experience.
This sounds incredibly useful, especially if you're building AI tools that need to actually solve complex things reliably. How would someone, get started with this? Is it available?
Yeah, what's really encouraging is that they've made this open source. It's implemented as a plugin within a library called optillm.
Optillm.
Yeah, it seems to be a library focused on helping people experiment with and improve LLM reasoning, prompting, that sort of thing. And they provide a simple command like pip install optillm to get it set up.
Okay, so it's accessible. How do you use it then?
They show a couple of modes. There's an inference mode. You basically just add a prefix, spliel, to the name of the model you want to use. So like SAPI-LGPT-4o.
Ah, so it wraps around the model call.
Exactly. It enables the SPL plugin to select and inject strategies before calling the base LLM. And then there's a learning mode.
For teaching it.
Right. You pass an extra parameter, something like splearning, true when you make the call. That tells the system to not just use strategies, but also evaluate the outcome and update its strategy database based on that interaction.
So you can actively train it on your specific types of problems.
Mm-hmm. And they even mention you can chain it with other capabilities in that optillm library, like memory or tool use, just by combining prefixes, like spell in memory GPT-4.
That sounds really flexible. Designed to be modular.
Yeah, it seems that way.
Okay, so let's summarize the payoff. If you, as a listener, or maybe a developer, or just someone using AI tools, what are the key benefits you get from this SPL approach?
Well, the biggest one is probably cumulative learning. The AI model or application actually gets better over time at the specific kinds of problems you give it. It learns from its successes and failures on your task.
Instead of being static. And the transparent knowledge piece seems huge, too.
Definitely. Being able to see the actual human-readable strategies the AI has learned gives you unprecedented insight into its reasoning process. It helps demystify how it's working.
Addresses that black box problem.
Right. Then there's efficiency. It reuses strategies that have proven successful
Right.
rather than trying to figure everything out from scratch every single time.
Makes sense. Saves computation, maybe.
Potentially, yeah. And adaptability. It uses different strategies for different kinds of problems. It's not a one-size-fits-all approach. It tailors its method.
And finally, it's inspectable. You can examine the learning process, see which strategies are being created, refined, used.
Yeah, all these together point towards AI that's not just more capable at solving hard problems, but also, more understandable, more predictable, and hopefully more trustworthy.
Okay, looking beyond just using it today, what about the future? The source mentions some pretty exciting possibilities.
Absolutely. One big area is developing really deep domain-specific expertise. Imagine an AI trained with SPL on, say, legal documents. It could learn highly specialized strategies for analyzing cases, or in medicine, learning diagnostic approaches.
Learning the art as well as the science of a field through experience.
Kind of, yeah, learning the effective procedures. Another idea is collaborative learning. What if different users or organizations could share their learned strategy databases?
Oh, interesting. Like pooling the AI's learned wisdom.
Exactly. You could potentially bootstrap an AI's expertise in a new area much faster by leveraging strategies learned elsewhere. And building on that, human-AI collaboration.
How so?
Human experts could actually look at the AI's learned strategies, maybe refine them, correct them, or even contribute entirely new strategies based on their own expertise. It becomes more of a partnership in building knowledge.
A human teaching the AI better ways to think.
And finally, they mentioned extending this beyond just text, thinking about multimodal strategies, learning how to solve problems that involve images or sound or other data types, not just language.
Wow. So connecting us back to you, the listener, what this suggests is that future AI interactions might feel very different. Instead of just using a pre-trained model, you might be interacting with systems that are actively learning and getting better at solving your specific kinds of problems over time.
And doing so in a way that's potentially more transparent, where you can understand how it's arriving at solutions.
It really feels like a step towards AI that doesn't just, know stuff, but actually learns how to think, how to strategize from its own experience, more like a collaborator.
Yeah, learning to build that internal playbook, that practical wisdom.
Okay, so to wrap up this deep dive then, system prompt learning, SPL, it's this really powerful idea about enabling AI to learn explicit, understandable problem-solving strategies directly from interacting with problems.
Hmm.
It helps bridge that system prompt gap, where basic prompts limit performance and the results show significant gains, especially on complex tasks.
And it represents a move towards AI that's more adaptive, learns cumulatively, offers more transparency, and ultimately becomes, hopefully, a more effective problem-solving partner. It's teaching the AI how to reason in a structured way.
So here's a final thought for you to chew on. If an AI can learn to break down complex tasks into these clear, human-readable strategies, like that word problem example, what specific, maybe tricky or unique challenge in your own work or even your daily life would you most want an AI assistant to learn a custom strategy for? What process would you want it to master?
Or maybe thinking about it differently, what does it really mean for AI intelligence if it can not only find answers, but also learn and articulate the method for finding them? What does that kind of transparent, learned problem-solving capability signify?
Something to ponder.